We're live, I bet.
We're alive. I'm alive, Mike.
I'm alive.
I'm alive. I think, therefore I am.
I think you are.
Well, I think not.
Then
I
you're
think not, therefore I am not. How about that?
Invisible.
Yeah. Yeah, that's what we're going to talk about today is consciousness. I want to welcome those of you who are here in person. And Mike, I know that you've had some issues with an accident in your family, and you still made it here. Your wife is in the hospital?
No, she's home. Jane had a pickleball accident and was concerned about running into a wall, so she went down, which probably was smart, but in going down, she broke her left wrist and she broke her femur, right at the neck of the femur. So that was Wednesday. Wednesday night, they did the wrist surgery and put a plate in her left wrist. And Thursday night, she had a total hip replacement, which they say is a better thing to do when you're young and active and so on.
So she still qualifies?
Yes. For me, they'd probably do put me to sleep or something. But so she's, that was Thursday at 5 in the afternoon. She had her hip surgery. By 10 o'clock, she was walking in the room and stayed that Thursday night. Friday, we brought her home. And so she's been sleeping at home and happy about that. And
wow.
Everything seems to be going well. She's moving around well. She can stand up. We've had a nice reach out from Reverend Mandy reached out to us, and so did the Pastoral Ministry Association with Cheryl Milan and so on. So thanks to the church and the people here with their nice thoughts, and thanks to you for your nice thoughts too.
Yeah, well, it's one of the things that is rewarding about being a member of a community. People to care, people to share ideas with, successes and challenges, and catastrophes, major or minor. I really feel really enriched by being a member of this church, in addition to being a member of the Humanist group that sponsors this series. I happen to be the president of the local Humanist group. We are a philosophical group oriented towards a positive view of human nature and progress and flourishing, things like equality and environmentalism are important to us, but it's also comports well with a lot of the priorities of this church. So I've found a nice home here. Mike, I think you have too.
Right.
So we also thank the church for giving us this physical space and the setup that allows us to be broadcast to you and to be here live.
And the psychological space that it gives us too,
right,
of support and interest in what is of interest to us.
Right, humanists, and I certainly speak for myself. I believe I speak for Mike and many other humanists that I know. We are not persuaded that anything that might be called magical or supernatural has any real existence in the universe.
Woo-woo.
Yeah, and it's nice to find a community here at the DuPage Unitarian Church where that kind of metaphysics is not just tolerated, but welcomed.
Just as an aside, I was at the service today too, and they had a couple people come up and talk about vulnerability and fitting into the world and where their vulnerabilities rested, and they had some very interesting, compelling stories of ways that announcing their vulnerabilities here at this church meant a lot to them because there was reward and support and care and concern for them as well too. So it was very powerful to me to hear that, thinking I didn't really get here in time to announce to anybody ahead of time to make it church announcements and joys and concerns or whatever that Jane had been hurt, but knowing that that's there if and when you need it,
right,
is very, very powerful to me about this place and about humanism as well.
Right, and so there are people here in person today. I do request that if you're able and in the area, proximal to this establishment physically, that you show up when you're able to do so. It really enriches the experience of having a dynamic conversation during these Science Sunday programs. It also makes us feel better, Mike and I, to know that we're not just speaking to an empty room. There are people here today. That is heartening. I ask that if you can make it in the future during Science Sundays, that you do so also. If you're watching online, if at some point during any of our programs, but including today's program, if you like what we're saying, please give us a thumbs up there on YouTube, and also enter a comment. YouTube has an algorithm that recommends videos to people based upon their interests. So this one's going to be called Consciousness in the Brain. People who are interested in consciousness may find this YouTube video, but they're not likely to find it unless it has a good number of thumbs ups. So if you're watching it and you appreciate what we're doing, please give us a thumbs up. If you have a concern, leave it in the comments. If you have praise, leave it in the comments, and we'll appreciate that. All right, without further ado.
Yeah, let's talk about something about the brain, huh?
All right, the brain and consciousness. This is part of what I intend to be a three-part series to wrap up my part of the year up through May for Science Sundays. And we're going to talk today about consciousness with a focus on the way the brain works and maybe some philosophical notions about what constitutes consciousness. Here are some of the books I've used to inform today's discussion. I am not a practicing scientist. I'm not an expert in any particular area, but I am something of a polymath in terms of my interests. If it moves, if it's real, if it's interesting to scientists, I'm likely to be interested in it too. Mike, I think you have a similar disposition.
I like shorter words, though, than you do, I think.
Yeah.
Like I say, instead of proximal to this facility, I would say near us.
Oh, right. Yeah, I need a good editor. Real time, maybe.
But that's just how your mind works, I believe.
Yeah. Here's some more books that I've used to inform today's talk, and there are others I've read as well. I just decided that showing these 6 books, there'll be one other that I explicitly reference later, is enough to get you started if you're interested in learning some of what I've learned about the brain and consciousness. Some of these are more philosophical. Dan Dennett is a philosopher and a humanist. He is probably my favorite, one of my 2 favorite living philosophers.
He likes big words as well.
He does. He likes big words. That's one of the reasons I enjoy his books. And Steven Pinker likes lots of words.
Yeah.
He tends to go on a bit when he finds a topic that he wants to discuss. All right, part 1, definitions and key concepts. Some of the ideas that philosophers and cognitive scientists bandy around, I think are pretty loosely defined. I come from a background of physics and astrophysics, and one of the things in what's called the hard sciences, physics and chemistry, one of the things that happens in those domains is pretty clear definitions until you get to the point of dealing with quantum mechanics, but we're not going to talk about that today. In any case, when talking about cognitive science and philosophy, people really get tied up a lot with the concept of definitions. What do different things mean? What do they mean in different contexts? And some of the ideas that are discussed and investigated in cognitive science are fairly unique to that field of science. One of those terms is qualia. A qualia is supposed to be what it's like to. What it's like to see red, what it's like to feel sad or feel happy, what it's like to taste spaghetti, right? So these kinds of things are accessible to everyone with a normally functional brain and body. We know what it's like to see red and to taste spaghetti, but it's really hard to describe. and cognitive scientists and philosophers have recognized this challenge. And some philosophers have posited that qualia exist independently of the functioning of the brain, that what it's like to see red or what it's like to taste spaghetti cannot be sufficiently explained by looking at the way neurons work. Right? You all know neurons are special cells that are compacted within the brain. We have neurons throughout our body as well. Talk more about that in a little bit. But there are some philosophers, and indeed some scientists, who say that the connection between what it's like to and the way neurons work, that connection has not been sufficiently established phenomenologically, one of those words again, by scientists and philosophers, right? So one of the things that translates to is what the philosopher David Chalmers calls the hard problem of consciousness. According to David, he's curious about how sensory inputs become qualia, or experiences. The old chestnut, what is the color red? Different people experience the same thing when they see the color red, etc. It's, in my opinion, it's a natural phenomena mediated by physical senses. And it's not just my opinion. Pretty much every monist, that's a person who doesn't believe in something in addition to the workings of chemistry, physics, and biology that is entailed in the functioning of organisms. A monist like me, whether it's a philosopher or a cognitive science, will say it is only the action of neurons. It may not be well understood, it may not be perfectly well specified and described, but there is no magic. There is nothing going on besides the way neurons do their jobs. I am a completely convinced advocate of that point of view. So if you come to this discussion with the concept that there is some kind of spirit or force, or that consciousness is innate in molecules and atoms, there's this idea of panpsychism, that the only way we can explain psychology and consciousness is to presume that it's built up from fundamental particles, that electrons and protons have a tiny bit of consciousness to contribute to whatever organism that they end up constituting. I am not convinced of that. In fact, I'm opposed to that idea. So if that's the way you come today with that preconception, I will be kind and polite to you, but I will probably argue with you if you mention that. It is physical processes. It's the physical processes of neurons that couple properties of the external world to concomitant properties of internal reception, integration, and response. One of the things that I've talked and written about in the past is the idea that each of us carries in our functioning adult mind, well-functioning adult mind, a model of the universe within which we find ourselves embedded. One of the other lessons I take from physics is that all interactions are local. I'm going to write more about that in my second book that's pending. Finishing it. I'm about 95% done, I think. But one of the profound concepts we can take from the physics of relativity is that all interactions are local. If you see a star, it's because the light emitted by that star hundreds or thousands or millions of years ago hits a photoreceptor in your eye right now. So you respond to a local phenomena, which is the presence of that photon, though it may have traveled for a long time and distance. The perceptions that we have are all local to our senses. And because we live in a real world with cliffs and falling branches and falling rocks, pickleball games, and other entities that move around in the world, it behooves us from an evolutionary standpoint to have the capacity to construct an accurate model of the world, right? If your view of the world around you is inaccurate, you're probably going to be accused of having a mental illness, first of all, but secondly, you're going to have some significant survival challenges. So one of the ways we know that the models we build in our heads are accurate is that we are alive. We continue to thrive in this world.
Not only we, but we as a species.
Right.
Evolutionarily.
Right.
Yeah.
So
But then so do other creatures, worms and
right, I'm going to talk
ants
about
and-
that.
yeah.
That's great that you bring up worms. There's some really profound cognitive science to be learned from the lesson of a worm, and I'm going to talk about that in a few minutes. All right, the hard question. Daniel Dennett says that there's no such thing as the hard problem, such as David Chalmers presents it. Instead, it's what Dennett calls the hard question. It's a difficult question to solve, but it has a physical solution. So Dan Dennett distinguishes between the mythological hard problem, which is kind of a backdoor into what's called dualism, the idea that there's physical stuff and then there's magical stuff. That's kind of a dualistic view in the view of philosophers. So the hard problem, as Chalmers characterizes it, is kind of a backdoor into dualism. That's what most philosophers who read him read into what he's saying. So Dan Dennett says it's a hard question. It's a difficult question to probe and solve, but it's still a question that is in principle something we can solve and understand. All right, dualism, right? I talked about that just a second ago. It's this idea that there is sort of a magical component of being a conscious being. Maybe there's some kind of mirror world where your spirit thrives, etc. If you have this metaphysical notion as part of your worldview, you're not alone. I'd say most people on earth believe in some kind of dualism. So I'm not here to criticize that from the perspective of philosophy and religion. What I am here to say is that I think it is perfectly sufficient to be able to explain the way brains and consciousness work without appeals to that kind of thinking.
Does it seem like dualism is almost a special exception or a special application towards humans, whereas the people don't tend to see dualism in apples or horses or
Yeah.
dogs or different things like that, except for maybe certain flashes of some kind of consciousness or whatever. But it seems like a way to explain
The
humans'
specialness
capacity.
of humans. Yeah.
I mean, I don't think people look at dualism, and I don't think they associate that with other animals in the kingdom of animals.
Yeah, you're probably right. I don't know enough about it to know whether a significant portion of dualists think that chimpanzees and dolphins and other high-functioning mammals have a spirit or not. Certainly some native Indian beliefs, panpsychism or I can't think of the word right now. Sorry, my $2 word.
Pantheism?
Pantheism, yeah, that trees and rocks and everything has a kind of spirit. So there's certainly this idea that spirit can be ascribed to things other than humans, but generally speaking, it's a concept that applies to humans.
Or best expressed or most easily
Right.
understood or explored or discussed in human nature.
Right. All right. So dualism, in my opinion, is nonsense. Right? There's no scientific evidence, no persuasive, repeatable, laboratory-controlled, blind study, name your constraint in terms of experimentalism. There is no evidence of dualism being real in our universe. Unfortunately, it may be awesome to be able to project my spirit
Yeah,
somewhere.
certain people feel like there's
Yeah.
evidence of dualism by,
Again, this is my opinion.
yeah.
All right. All right. Life. Some interesting properties of life. Life requires, assembles, maintains a boundary. There's a distinction between you and the rest of the universe. And any information you get about the universe as it relates to you, you obtain through your senses. Now, we've been able to augment our senses with devices like telescopes. Before telescopes, a given human being could expect to see about 5,000 stars. That's it. On a dark night, before artificial lighting, on the savannas of Africa or in the far north Arctic, no matter where you were on the planet, you could see throughout a year, you could count about 5,000 stars. Well, now we know there are billions and billions of them. And that's because our senses have been augmented by devices that allow us to apprehend information about the world that extends beyond our immediate sensory reach. Life also processes matter and energy. It has metabolism. The idea of disembodied life, literally disembodied, having no body, having no material to shove around, just doesn't make any sense. Energy, when it's free in the universe, tends to move as waves or as light, and energy doesn't organize. It takes matter to organize things. And fortunately, life is all about the organized assembly of matter and the way it uses energy to reorganize itself in specific ways. And of course, life processes information. Even simple life processes information. Consciousness is another term that's used a lot. I think it's fair to say consciousness is a continuum of stimulus-response, volitional behavior, and model building or model manipulation. And different organisms may have different capacities vis-a-vis these characteristics, right? Think about model manipulation. We have a model of reality in our mind, and we can think about what it would mean to make spaghetti. We can think about what would go into the recipe, or when we might do it, or how much we might make. That's manipulating the model of spaghetti we carry around in our head. We can expect that certain simple organisms, like bacterium and prokaryotes and protists and whatnot, have a very limited, if any, capability to manipulate the models that they have inside themselves about the status of the external world. So consciousness, I believe, is a continuum that expresses itself among these various characteristics. It's probably too squishy to define consciousness clearly. Having read several books and papers about consciousness, I begin to think that some people mean different things by the same term when they use it. And so I would like to see us use more specific terms, like stimulus response, like manipulating concepts and models. I think that if we use vocabulary that's a little clearer about what it is we're talking about in a particular context, we can avoid using a squishy, perhaps even ill-defined term like consciousness. Instead, we can consider using clearer terms like stimulus response, volitional action, conceptualization, planning, and self-reflection. All right, let's see. One of the other things about consciousness is this notion of being self-aware. We suspect that self-awareness is a capacity that has evolved relatively recently. There is some evidence that certain species besides humans can be self-aware, can have a modicum of self-awareness, like the chimpanzee that'll try to rub a spot off its forehead if it looks in a mirror, etc. So self-awareness is not uniquely the domain of being a human being, although our capacity for self-awareness seems to be extraordinary, as are our capacities to manipulate and form models. I think, and most philosophers and cognitive scientists think, that that's just more of the same. Nature evolved capacities to evince that kind of behavior and the way brains work, and humans ended up with that capacity in an abundance not seen in any other extant species. All right, let's talk about the consciousness of a single cell. Again, squishy term, but we can think about single cells that have aversion and preference kinds of behaviors, right? Particular thermal gradients or chemical gradients or
Saline or...
right, physical stimulus, etc., can cause a reaction in a simple bacterium. So is a bacterium conscious? It reacts to its world. It has preference-seeking behaviors. It prefers some chemicals over others. It has aversions to some, right? So a bacterium behaves as if it has volitional behaviors that are tied to its relationship vis-a-vis the external world. So
It utilizes all the capacities it has to interact with the world, I was just thinking. And we use the capacities we have to interact with the world.
right.
Most living things interact in a volitional manner with the world.
Right, right. Plants are a little different in that they typically aren't motile, but they still react to their environment in various ways. But the fans of panpsychism, who think that consciousness is an innate property of fundamental particles, etc., may feel quite comfortable saying that a paramecium is conscious, right? In their metaphysics, that's a perfectly valid use of the word consciousness. And again, it signifies to me an example of where using a clearer vocabulary will help us sort out what kinds of concepts we can constructively talk about with such a person, rather than using something squishy like consciousness. I talked a little bit about the models that we build in our head, right? Some of the models we build are external to our heads. We build computer programs which can model certain capabilities of things in the real world. Back in the 1600s and 1700s, these ORAs, these models of the solar system, were a popular gadget in the parlors of well-to-do folks who were interested in natural science and natural philosophy. So our ability to build models, we're probably the only extant species. I keep saying extant because Neanderthals and Homo heidelbergensis and some of the other precursors to human beings likely had some of the capacities that we share. And if you are an advocate of evolution, which I am, and I know you are as well, then certainly these capacities that we have evolved over time, including throughout the human lineage. But in any case, the ability to build models external to ourselves in databases or in physical constructs that help us understand the world and we manipulate those external models as a proxy for manipulating real things in the world to help us learn what's possible and real. This is a characteristic of humans. We instantiate our models as physical things. I propose, and many others do as well, that the models we carry in our heads are just as physical as an ORA, but they're made up of neurons and the connections between neurons and the chemical stores and currents that exist in our minds as well. But just like you could build an ORA out of Lego blocks, you could build a model of the solar system out of neurons. All right.
You'd almost think that in order to be able to create a physical model like an ORA, you would need to have the model created previously in your mind, or
Right.
substantively along with it. As you're creating one, you're creating it in your mind as well.
Yeah, well, look at the way children play. A lot of what children do during their play is modeling the world, whether it's action figures or dolls or model cars or choo-choo trains or, you name it, model kitchen appliances. think about the kinds of toys that a child typically plays with. They're building models of the world. They're acting out things with the help of an external object that helps them grasp some of the models they're manipulating,
Yeah, I'm just,
literally.
don't get me started because my granddaughter is a year and a half and we're just watching all the things on video chats and things like that she can do, and it's just amazing to see from week to week. All of a sudden now she's getting these concepts of red, and she puts all the red elephants in a red cup and the blue elephants are going in a blue cup. And I'm trying to, process how is that really happening. And I think a lot of it is because she's seen so many books and different things that are already modeling, like there's a book with blue page, a page of all blue pictures and a page. So she's just creating this set in her mind
Right.
of blue and red and so on. And it doesn't matter if it's elephant, whatever
Elephants,
it is.
marbles, or books.
Right.
Yeah.
And so you can see this process developing. It's going along in her place, so.
Right, and I'm going to talk more about that. I'm probably going to go a little over today. I love this topic. I hope you do too. I hope you can stay another 15 minutes or so later than our scheduled time as I go through some of this. Simple cells interact with gradients in space, all right? Chemical gradients, salinity, right? Molecules that might be edible, that they can incorporate via their metabolism into building and maintaining their own internal structures. Cellular minds, if you will, the consciousness of a cell, works such that it operates effectively in a world where gradients in space are real, right? So that's the way that these minds in a cellular machine work. Some single-celled...
I just wonder how your mind works sometimes.
Thank you. More complex cells can use gradients in time. What does it take to use a gradient in time? What does it mean to have a gradient in time? It means something that changed between then and now. Well, how do you know what it was then? You have to have the capacity for memory. There are single cells in our world that have the ability to distinguish between things that happened in the past and things that are happening now. They have memory. They store within their physiology some kind of representation of the way the world used to be.
You have an example?
Yeah. A what? An amoeba can be trained to go through a maze. I think that's spatial, but temporal gradients in time are...
We can also train them to respond to a current for food.
respond to currents.
And a specific sequence for food.
Yeah, sequences.
It can be a big sequence, but like a 3-pulse sequence, they can figure things out.
Yeah, so the mic isn't on Joanne, but she's talking about pulses and sequences. They can be, some simple multicellular organisms can react to pulses in time and begin to anticipate that. Certainly worm brains and whatnot can do that. Complex cells can use gradients in time. I'm trying to think of the example in the book. I can't
I'm just
dig it
wondering
out
if
right
there's
now.
like a certain
Canonical.
electrical pulse they're trained to go left, and another electrical pulse they're turned to go right in a maze.
Yeah.
So you can train it every time it goes left. You give it an impulse. It's almost like stimulus response or behavioral.
But one of the
Training too.
key things I wanted to point out about these cellular organisms is that they don't have neurons, right? They're exhibiting this complicated behavior that responds to their environments, gradients in space, gradients in time, without neurons. So it doesn't require a neuron. A single cell, a eukaryotic cell, a cell with a nucleus and a lot of organelles, what we call a complex cell, is sufficiently complex to do some sophisticated processing, even though it's not a neuron. And imagine what happens if that single cell becomes specialized in information processing. All of the capacities for responding to gradients in space and time could become amplified, and it could deal with gradients over its surface or along the length of an axon, for example. Different gradients at different points along an axon, different chemical signals, etc. So it's pretty reasonable to extrapolate how cells can evolve the ability to process information from a complex panoply of inputs for a given cell. All right. Now, the kind of memory that we think of when we think of human memory requires neurons, the capacity to store abstract information about what spaghetti is, about where our house is located, etc. These kinds of capabilities, as far as scientists have been able to ascertain, are a manifestation of the behavior of neurons. There's some evidence that cells called astrocytes, which are kind of the scaffolding cells in the brain, astrocytes are also implicated in some information processing as well, so maybe there are cells besides neurons that help with some of the cognitive capabilities that we have. But memory in some form is required for time-related gradients. And you can see that processing time-related information becomes critical to survival. You have to know about changes in seasons. Those are long-duration, time-centric events, changes from moment to moment. Looking at a football that is thrown at you and deciding how to catch it and when, that's all processing time-related stimuli. Signaling is required for sending information over non-trivial distances, so neurons have evolved long extensions in their cell bodies to be able to send information long distance. The amazing neuron, it has cascading signals, signals that begin at one neuron, can cascade to other neurons in a very specific and organized way, such that we can ascribe the concept of networking to neurons. Memory, certainly, I talked about that, and processing, information processing, essentially making decisions, this and that, this or that, one or the other, both. Those kinds of decision-making basic capabilities are things that neurons are able to do. This gives rise to computation and memory-specific structures that can eventually build models that are fairly complicated. All right, let's talk a little more about the worm brain.
Yay.
Here's an interesting thing that was in that book about the mind of an octopus, I think was the book I got this out of. And I was astonished to think about this. If you touch a worm right on its snout, the worm will recoil. But when a worm is digging through the earth, things touch its snout all the time, and it doesn't recoil. So the worm has the capacity to distinguish between sensory input that is in response to its own volitional behavior versus sensory input of the same sort that has no correlate to its own volitional behavior. Think about that. That's a pretty complicated task, and a worm brain can do it. Also, I want to talk about the mantis shrimp a little bit. The mantis shrimp has some of the most, if not the most, complicated photoreceptors of any organism on Earth. It can detect polarized light. It has something, I think I wrote it down in my notes here. Mantis shrimp. I don't see it in my notes, so I'm likely to get the number wrong. But it has, you know how we have red, green, and blue, and then dim and bright or black and white photoreceptors in our eyes. We have 4 kinds of photoreceptors. The mantis shrimp has many. I don't remember the number, so I'm not going to tell you, but I can't tell you. But it has many different kinds of photoreceptors. So the most robust ability to perceive different frequencies of light seems to be evolved in this tiny little mantis shrimp. It can also detect light polarization, which we only have a rudimentary capability to do. Why would evolution have loaded mantis eyes with all of this capability when we only get 3 or 4 photoreceptors, different types of photoreceptors? A plausible explanation is that the mantis shrimp brain doesn't have to do much complicated processing. All of the processing that it needs for interacting with the world via visual stimuli, most of that processing is done in the eye by having the ability to distinguish different kinds of light, different orientations of light polarization, etc. So the processing of information from the physical world is built into the structure of the eye rather than in the capacity of the brain.
This is, Siri says the mantis shrimp has anywhere from 12 to 16 different photoreceptors in its midband.
Yeah, I was thinking 12, but I wasn't going to say it. So yeah, that comports with what I'm vaguely remembering. Thank you, Mike. So,
They can see UV, visible, and polarized light.
cool.
Yeah.
All right, talking about fantastic capabilities of brains and structures that are offloaded from brains, did you know that your dog can do calculus? It's true. Every time your dog follows a frisbee and catches it out of the air, your dog is solving calculus problems in a way that has been pre-programmed by evolution. The capabilities for solving calculus problems on this planet, the particular subset of calculus problems we can solve, depend upon the kinds of gradients we encounter on this planet. The strength of the gravitational field, the way temperature varies from place to place. These create gradients in the natural world. And we have to have the ability to navigate these gradients in a safe or fun manner. A dog, when it's chasing and catching a frisbee, is solving calculus that's been programmed into its brain by evolution. That is amazing. Now, if you were to look for dy over dx, or the integral sign, or definite versus indefinite integrals, or tables of logarithms, and all of these kinds of things, if you were to try and look for those in the brain of a dog, you will not find them. It's one of the capacities of human modeling and human language building that we can build abstract models of the way the world works, and we represent that with particular symbols that we've invented, like the integral sign, like dy by dx, etc. Right? The symbols we use to express these concepts are unique to the language we've developed, the language of mathematics. But the capacity to do the calculations is something that evolution has built.
But you'd imagine that the dog, as a young dog first seeing a thrown frisbee, would not know what to do very well, right? It's
Right.
also a function of
Learning.
practice and learning and involvement and interest, or whatever, right? That the dog's interested in doing it, and it gets success, it gets praise and feedback and treats when it catches it, and so then it starts calculating it. But it is an amazing feat.
Yeah. And in case some of you who are watching this are taking a calculus course, don't think that playing frisbee with your dog substitutes for homework.
That was my problem
Yeah.
my first year of college
I was doing calculus problems with Rover.
on the quad.
Yeah. All right. So I talked about it just a moment ago with respect to the dog, but language is also an amazing capacity that we have to symbolically represent different aspects of the world, the external state of the world, and our internal state. I feel tired. I feel happy. I feel worried about Jane. I feel sympathy for you. I feel comfortable in this space. I feel glad to see all of you people here today. We can represent our internal states with language just like we can represent external states. I can imagine if one of you started yelling at me, I would become unhappy, right? So I can also manipulate these concepts in my mind to imagine what it would be like, or what my internal state would be like under different contexts. That's just manipulating our model of the world. Our model of the world includes our model of frisbees and trees and spaghetti, but our model of the world also includes our internal status and state. So it's an incredibly sophisticated model. Dan Dennett and Steven Pinker talk a lot about memes, this idea that Richard Dawkins came up with, that ideas, sort of atomic level ideas, originate in our cultures and then get transmitted from person to person and changed and embellished and whatnot. There's some problems with the analogy between genes and memes, and Pinker does a good job of picking out some of those problems. But it's a pretty useful idea that ideas are able to be transmitted from person to person with language, whether it's the language of English as spoken or as written, or the language of mathematics, or any other language. Morse code or smoke signals. Choose your proxy for conveying information. Well, if we know our internal states, that's a big step towards being able to model how we interact in the world. We can correlate external changes or models of external changes with models of how our internal state changes with respect to those. But one of the things that we have a capacity to do as a social organism is that we can create models of other people's minds. That's fascinating. I can imagine what it feels like for you to have a wife that is injured, because I have a spouse, right? The ability to have empathy, the ability to cooperate. Many of the emotions and motivations we have are social-oriented motivations. And the reason we can do that, the way we can do that, is because we have the capacity to build a theory of other people's minds, not just a theory of our own mind. You can imagine, in a science fiction context, that there could be beings that are autonomous, like a lion. There are beings on this planet that are solitary beings, snow leopards, right? They only meet once in a while for mating, and that's about it. Otherwise, they're solitary. It occurs to me that if we were not a social species, if we did not respond to things like shame and convivial conversation and laughter and theater, if we were solitary beings, if we had evolved as solitary beings that met every mating season and otherwise kept to ourselves, we probably would not have as sophisticated a capability evolved through natural selection to model other people's minds. And a lot of the social kinds of behaviors we engage in would be irrelevant or pure happenstance. So having a theory of mind is also an incredible part of being a conscious human being. And think about the complexity of modeling a person's mind. Every time you read a fictional novel, the author has modeled other minds through language, right? Every time you understand that a person is staring at a plate of cookies and not paying attention to you, you have the capability to model what's going on in their mind. It's an amazing capability. It's one of the most amazing capabilities that the human brain has. And once again, it's just embellishing this concept of our ability to build models in our head. We can build models of other people. Obviously,
Is
they're
that a
limited.
human trait, or is that a higher?
Dogs
animal
can do it, right? Dogs know where you point. They're the only species that respond to where we're looking. If you look at a thing, a dog will look at what you're looking at. It's the only species on Earth besides humans that'll do that.
I'd be interested. I kind of wonder about elephants or different things too, maybe, but
Yeah.
I don't know. I hadn't heard that expressed. I hadn't heard that claimed.
So the ability to model other minds in a rudimentary way is something that dogs have. There may be other animals that can do it for members of their species, right?
I've had dumb dogs who usually look at the tip of my finger when
Well,
I point
yeah.
at things.
Probably can't catch Frisbee either and out of the air. All right, anyway, fantastic capability. And it's just something brains do once they have the capacity, an extraordinarily amplified capacity to build models of reality, including the reality of other people's minds. Right, physicist turned cognitive scientist Leonard Mlodinow and others, I believe that Pinker and Dennett emphasize this as well, and there are many others, the role of emotion in cognition. Some people imagine, if you're familiar with the science fiction show Star Trek, the original version of Star Trek that had Spock, a perfectly rational being with no emotional responses. If such a being existed, that being would be moribund. It wouldn't do anything, wouldn't be curious about anything, wouldn't give a darn about helping others, right? Without emotion to motivate us, nothing happens in our lives. If you look at people with clinical depression, one of the problems they have is with motivation. They are not feeling things like a typical brain would, right? They're not feeling, they're not reacting, they have a limited capacity for empathizing. So we consider that a pathology, but it's a pathology based upon the emotional state of our brain, not the cognitive models in our mind. So emotion is important. But if you think back to that single cell living in that saline gradient, well, it wants to go towards or it wants to go away from the saltiness. So emotion is nothing more than an amplified capacity for aversion and attraction to various stimuli. But because it's been tied into our ability to create very complicated models, including models of other minds, our view of the universe, our perception of the universe, our capacity to model the universe is enriched by being able to attach aversions and attractions and other emotions to the complexity and the richness of the models we build of the universe. Some people look at the stars and have an attraction to them, have a curiosity and a fascination. Other people, and I've known people like this, other people look at the stars and go, yeah, so, right? So the things that you're motivated by may be peculiar to you, but you do have motivations. And they're nothing more than amplified capacities for developing attractions and aversions that have been amplified by natural selection to embody such capacities as a survival instinct.
I'd push back on that
Okay.
a little bit. I'd say that just because two different phenomenons cause a similar result doesn't mean that they're tied or amplified or one is the direct antecedent of the other or one comes about because of that. I mean, you know, that could be a case of an evolutionary survival that the amoebas or the single-celled animals that didn't move away from a certain salinity died out,
Perished, right.
So if those perished, the others would pass along, the others would move on, and you'd find the ones that by some odd feature do that better than others succeed. That doesn't mean necessarily to me that emotions are the same
Right.
function there.
That is a fantastic point, and I'm glad you brought it up.
Okay.
I thought about this as well, Mike. So Let me organize my thought about this. It gets back to the notion of qualia and dualism. Follow me on this. So, what it means to be awestruck by the stars, right? If there is something besides the mechanical working of the cells and the chemicals in your brain, then there's something extra that goes into the emotion of feeling awestruck by standing under a night sky resplendent with the Milky Way, right? But if it's purely the mechanical operation of the brain, then your particular brain, as a person enamored with astronomy, your particular brain responds with a sense of complicated emotions, but at the very least, a curiosity and an attraction to the concept of the night sky. Deep down, when you're talking about neurons and the functioning of the brain, that if you're a monist, if insofar as you ascribe to the idea that there is nothing in addition to the operation of neurons, deep down in the brain, all that is that some neurons in your brain have evolved to have a heightened response to that stimuli. And part of that heightened response is that they're tied in to the emotional centers. Imagine the emotional center of your brain as a switchboard with 5,000 sliders that go from 0 to negative and 0 to positive. A single cell may only have one of those sliders, right? An aversion or an attraction. We have billions of neurons in our brains, and we have, I don't know how many of those sliders, how many different distinct emotions have been identified. I actually read about that. I forgot the number. But something like 1,000 or 5,000 distinct sliders in our mind. And what it feels like to be curious, what it feels like to be angry, what it feels like to be excited, we have some kind of visceral sense of that. But if you subtract out that embellishment, it is perfectly sufficient to say we just have these sliders, these potentiometers in our brain that are controlling various responses, either positive or negative, to different stimuli. That's all it can be, unless you want to reinvent the idea of qualia and dualism, something in addition to, something extra than some kind of determination of a gradient.
Yeah, I'm thinking that learning can be very pleasant if you've had a lot of experiences that teach you how wonderful it is to learn about the stars or to learn about red elephants and different things like that. Then you have a quality built up in you that's maybe evolutionarily blessed or established, but it's just something that you've been built for
Right.
years that has been, rewarded by your parents
Yes.
and by society and different things. And so those are things that then, this learning is a pleasant experience for you.
Right. Well, I believe that all typical human brains in infants and children, all typical human brains are built with an appetite for wonder and a capacity for curiosity and learning. I think that's just part of what we inherit as an instinct.
Evolutionarily established or whatever
Right.
as well.
If a human baby is born and it isn't curious, it's not going to thrive as a person. All right, but emotion is important, and my key point is that emotion can be perfectly well modeled as a series of sliders. But by the time it gets to our conscious mind, those sliders have been so abstracted and so intertwined with other responses like our heart rate or physiological responses or other parts of our
Hormones flowing, yeah.
It's so intertwined with our physiology and our manipulation of our mental models that the abstraction of those emotions being just gradients that are kept track of by different patches of neurons, that is completely opaque to us, completely lost to our conscious mind. Self-awareness is a model of self. Consciousness may be thought of as awareness plus alertness, right? Think about what anesthesia means. You're neither aware nor alert. So awareness and alertness. Animals can be anesthetized. They can become devoid of awareness and alertness, but they're still alive. They still have brains. And then you may also, depending upon how you want to talk about consciousness in a particular context, you may want to add the ability of thoughtfulness, of deliberately manipulating models of yourself and the world through mental gymnastics. Human exceptionalism is the complexity of thoughtfulness that we have. We have different capacities within our mind. How do we identify it when it happens? How do we comport something with a model? When we apprehend new information about the world or ourselves, how do we fit that into an existing model? Or do we embellish the models we have? I have this idea that as we go through life as children, we are constructing ever more complicated models, but our tendency as adults is to fit things, new things we experience, we want to fit them into our existing model. We're less apt to build on new parts of a model. And I think that's just part of the way the brain matures. There's a pruning of synapses and whatnot that happens during late adolescence. All right, read that sentence, the last sentence I put on the slide. How many of you thought about the thing used to shoot arrows? How many of you thought about something you put around a present? How many of you thought about greeting somebody? Right? So one of the wonderful things about having these models in our mind is fluidity, the ability to, in programming, object-oriented programming is called overloading. You can overload a concept with many different operations. And so we can have a complexity and a richness of our minds and our models, and certainly of our language, that is only revealed through context, which is one of the reasons that artificial intelligence has such problems with language. I'll talk a lot more about that in the next lecture. All right. And then I also want to talk about damming the stream of consciousness. One of the things I can do is I can be quiet and easily transition to a mental state where there are no words that I'm latching onto. The way that I had described it to people is my brain is like a river of flowing stuff. And whenever I think in words, I'm dipping a bucket into that river and I'm pulling out a concept and I'm verbalizing it in my mind. And I have the capability to just let the river flow. I have the ability to flow, to let concepts flow without needing to verbalize them. And I think that's a capability a lot of people have, and those that don't recognize it in themselves can develop it. And it's kind of fun to be brainless. I don't know what you'd call it for a while.
When you're knitting or crocheting, maybe.
Right. All right. Is that it? Oh, yeah, I wanted to, this is, and then, boy, I'm running out of time. This is a model of the brain of a worm. This is C. elegans. And it has exactly 302 neurons. About 1/3 of all the cells in its body are dedicated to its brain. It has about 8,000 connections, half of which vary among individuals. So every C. elegans will have about 4,000 of the same connections and about 4,000 unique connections. It has 118 different kinds of neuron out of 302 neurons. Neurons come in kinds. A single neuron in a worm's brain can express about 14 different neurotransmitter receptors, the chemicals that signal between neurons. And this is in a worm that's about 1 millimeter in size.
There's a lot of talk about them in genetics too, where they always have the exact same amount of genes.
Right.
Very structured, very important animal for scientific study because so many aspects of it are so similar across the,
A C. elegans is a C. elegans. Kind
Right.
of thing, yeah. Here is, recently, I gave this talk the first time about 3 weeks ago, and since that talk came out, there's been a scientific paper published about the morphology of a fruit fly brain. A fruit fly brain has 3,016 neurons, and among those neurons, it has 548,000 synaptic connections. This is a model of the fruit fly brain. 3,000 neurons, nearly 550,000 connections. And then this is the human brain. It has 86 billion neurons. Now, a question I have is, does every human being have 86,459,372 neurons, right? There is some evidence that the human brain can certainly construct new synapses, but also regenerate neurons and whatnot. So there's probably a difference in the number of neurons between human brains, but about 86 billion. The number used to be 100 billion. Recently, they've winnowed it down to 86 billion. Perhaps 10,000 different kinds of neurons. It has the capacity for conscious states. One of the books I read talks about the what module, the why module, and the where module. The what module is identifying objects and situations. The why module says, or wow, right? The why module is the part that loads it with emotion, either aversion or attraction. And the where module is, how does it relate to my location in space and time? And then non-conscious resonant states, where many networks of neurons communicate and connect, speaking, navigating. During all of these, no qualia are produced. You can walk out of this church, and unless you explicitly think about it, you're just walking out of this church. There's no qualia. There's not what it's like to see the stairway, what it's like to grab the handrail, what it's like to feel the stair under your foot, what it's like to extend your foot to the next step, what it's like to feel carpet versus tile. None of this comes up to our conscious awareness. So we would say, in certain language used by certain philosophers and neuroscientists, they don't rise to the level of qualia, but we still navigate perfectly well. One of the other ideas is that the brain is fractal. It's networks of networks of networks of networks. A neuron is a network in of itself. Two neurons connected form a more complicated network. There's some evidence that every square millimeter of the surface of your neocortex constitutes a tube of neurons that go down about 2 millimeters, 2.5 millimeters. And that these are little cylindrical processing networks, and they're all networked together within your brain and to deeper parts of your brain. It's amazing stuff. And one of the concepts that helps enrich this, have you ever been at two minds? Like, should I eat the cake or not? I am on a diet. Maybe I should eat the cake anyway, because I've been a good person today, right? Have you ever been at two minds of something? Well, I should invest this money in a long-term bond. Or I could buy the new Apple iPhone. Have you ever been of more than two minds? You are thousands of minds. And the minds are all competing for your attention all the time. Which minds we pay attention to? Do we worry about the consequences, or do we concentrate on the immediate gratification, et cetera, et cetera? We are of many minds because we are made of many neural networks connected at different levels, some of which are attached to different physiological responses. The woohoo response versus the oh no, I better not response. Our neural networks can be fooled easily. The squares labeled A and B on that kind of checkerboard are exactly the same color. Nobody on earth that I have ever heard of sees them as the same color, perceives them as the same color. Our neurons and the networks within which they're enmeshed have generated all kinds of complicated shortcuts to help us navigate the world with the minimal amount of useful data. And these other optical illusions rely on tricking some of those shortcuts to sort of short circuit some of our perceptual networks. The brain is a dynamic structure. It is structured chaos. One of the things that neuroscience is beginning to highlight, and I'm really excited about this. This comports with something that just, not that anybody cares what I think, but I think it really gets close to something vitally important, is that typically what happens in learning is you're taking a noisy system. Remember the static on old TVs? You're taking a noisy system and you're imposing structure on it when you learn. So the brain and the neurons and the synapses are just busy all the time. And when you learn, you're pruning and paring that down. You're filtering the signal from the noise. Your brain generates all the noise, and what your learning does is it structures certain parts of that noise as learning. There are things we pay attention to and things we don't pay attention to, things that rise to conscious awareness and things that don't. A fly buzzing around, depending upon your context, probably won't catch your attention. Networks of networks learns by change and motion. It's a dynamic prediction machine. That's another thing about the brain. A lot of what it does is predicting. It predicts what it feels like to touch wood. It predicts what it feels like to walk on a floor. It predicts what it feels like to pick up a phone or hear a voice or to be exposed to sunlight. The brain is constantly predicting, and anything that violates that prediction makes you go, what? It immediately grabs your attention.
jarring,
Yeah, right? If a fly is buzzing around, we probably don't pay much attention to it, but if a bee is buzzing around, we are likely to pay more attention to it. Almost exactly the same stimuli. One of them rises to conscious awareness and the other doesn't. Consciousness is just the things that are able to be communicating with all kinds of different networks in the brain in a kind of volitional way. We can direct our consciousness to a certain extent. But the activity, the perception of the world, the forming of models, the prediction of what goes on, that happens all the time throughout your brain at a subconscious level. Some of these notions are in this book, A Thousand Brain, which talks about the little millimeter square and the tube of neurons in the neurocortex and whatnot. So, from many, one. I believe this is the best motto the United States has ever had, much better than In God We Trust. But that's a whole different topic. In any case, you are a cacophony. Your mind contains a legion of responses, aversions, attractions, billions upon billions of them. And you manifest as a cogent, consistent, predictable organism. If I know you, I'm probably going to know whether you prefer raisin or chocolate chip cookies. If I take you to a dessert bar at a buffet and I predict you're going to take the raisin cookie, does that mean that I've read your mind? In a way. In a way. I have a model of you in my head, and that model is either more or less accurate. And of course, we can surprise each other with our behavior and decide that we're going to shirk our diet and go for the chocolate chip and whatnot. And that's going to be the third lecture of this series, is I'm going to talk about free will. John Muir famously said that when we try to pick out anything by itself, we find it hitched to everything else in the universe. I predict that the same thing is true of the brain. Whenever we try to tug on one element of awareness or processing, we find it connected to nearly everything else in the brain. Emotions, reactions, physiology, different concepts. And creativity involves, in my opinion, the amplification of some of those connections which we might otherwise ignore, or a realization that one concept is connected to another in a surprising way. This is the end of part one. In April, we'll do part two, transformations of information, and some relationships to some recent discoveries in artificial intelligence. And then part three, as I alluded to, will be about free will. And that's all I had for today. Thank you for staying late.
Thank you. Science Sunday will be in 2 weeks, early April, and we're talking with Reverend Huizinga, Reverend Mandy, to see if she'll talk about, if she has the time to put in our talk about awe and wonder in the universe and science.
All right.
Great. Thanks, Scott. Very nice.
Yeah, anybody, I'm just here. This is my day. So anybody else have anything they want to share? Step up to the microphone.
I was wondering what you were thinking, Robert. You've got a lot of background in this field, and you've talked about things with us too.
Could you use the mic? Could you use the mic? Yeah.
This helped me get more into depth about some of the concepts they were describing, so I really appreciated it. I was reminded in some points about books like The Body Keeps the Score. The Body Keeps the Score, and how consciousness is not just locked into the brain with the neuron, but your body and the various tensions and
Right.
it's all a part of thinking in a way, and remembering and not remembering. It's the complexity is just amazing.
And Leonard Mlodinow, in his book, spends a great deal of time. His book is called Emotional, and at least the first half of it is about the way that the body is indispensable to the functioning of the brain and the concepts of self, etc.
You gave that talk about what are the
Adverse childhood experiences.
Right,
and
adverse
the impact
childhood
of trauma.
ACEs, adverse childhood experiences.
I was curious too about, you talked about one definition of dualism, but I often hear dualism as thinking of it's only binary choice. Things are either black or white, or yes or no, or and there's other definitions of dualism, but for this talk, you wanted to focus on that one type of meaning of dualism.
Yeah, I'm more familiar with the term dichotomy, and then there's the idea of a false dichotomy, which would have you choose between ostensibly two polar opposites, but in many cases there's a spectrum of opportunities in between.
I do regular mindful meditation, and they often talk about dualism as dichotomy.
Okay. All right.
I was also thinking of a couple of surgical performances. One of them was, again, so often this happens by accident. They're working on the brain, and a surgeon put an electrode into the brain, and suddenly the patient said, "I'm floating." And there's essentially a nexus there which says you are inside of your body, and if you turn that on or off, whatever the opposite is, you're floating. You do not have any experience of being within yourself, and then you hit it again, and you're back. There's also an on-off switch to the conscious mind. If you hit a certain nexus, you're gone.
Must
You
be a little
simply
network.
stop.
Yeah.
And you hit it again, and you turn it back on, and you're back.
Yeah.
And you go, where was I? Well, you were still here. It's just that there is a nexus there. And it also reminds me of the other studies that have gone with mirror neurons and the map which everyone has in their brain of their locus and everything around them. You have a map, literally, in your brain.
Literally a
it's
map,
laid out,
right, yeah.
And any place you have been, you can go back to.
Right.
And you keep adding to it.
Right.
So it's an amazing device, and we know so little of it.
Right. All right, well, thank you all for showing up. Thank you for those online who've watched this. Again, I kindly ask you to give us a thumbs up if you've enjoyed today's program, and we'll see you again in a couple weeks.
Great. There's thumbs up all around.
All right.